So if you look, FSD 10.6 just came out recently. 10.7 is on the way. Maybe 11 is on the way somewhere in the future.
Yeah. We were hoping to get 11 out this year, but it's 11 actually has a whole bunch of fundamental rewrites on the neural net architecture, and some fundamental improvements in creating vector space. So
there is some fundamental leap that really deserves the 11. I mean, that's a pretty cool number.
Yeah. 11 would be a single stack for all, one stack to rule them all. But there are just some really fundamental neural net architecture changes that will allow for much more capability, but at first they're going to have issues. So, we have this working on sort of alpha software, and it's good, but it's basically taking a whole bunch of C code and deleting a massive amount of C++ code and replacing it with a neural net. And Andre makes this point a lot, which is neural nets are kind of eating software. Over time, there's less and less conventional software, more and more neural net, which is still software, but it's still comes out to lines of software. But let's just more neural net stuff and less heuristics, basically. If you're more matrix based stuff and less heuristics based stuff, one of the big changes will be right now the neural nets will deliver a giant bag of points to the C++ or C and C++ code.
Yeah.
We call it the giant bag of points.
Yeah.
And it's so you got a pixel and something associated with that pixel. This pixel is probably car. This pixel is probably lane line. Then you've got to assemble this giant bag of points in the C code and turn it into vectors. And it does a pretty good job of it, but we need another layer of neural nets on top of that to take the giant bag of points and distill that down to vector space in the neural net part of the software as opposed to the heuristics part of the software. This is a big improvement.
Neural nets all the way down is what you want.
It's not even all neural nets, but it's this will be just this is a game changer to not have the bag of points, the giant bag of points that has to be assembled with many lines of C++, and have a neural net just assemble those into a vector. So that the neural net is outputting much less data. It's outputting this is a lane line, this is a curb, this is drivable space, this is a car, this is a pedestrian or a cyclist or something like that. It's outputting it's really outputting proper vectors to the C control code, as opposed to the sort of constructing the vectors in C, which we've done, I think, quite a good job of. But we're kind of hitting a local maximum on how well the C can do this. So this is really a big deal. And just all of the networks in the car need to move to surround video. There's still some legacy networks that are not surround video. And all of the training needs to move to surround video. And the efficiency of the training needs to get better, and it is. And then we need to move everything to raw photon counts as opposed to processed images.
Okay, so
which is quite a big reset on the training, because the system's trained on post-processed images. So we need to redo all the training to train against the raw photon counts instead of the post-processed image.
So ultimately, it's kind of reducing the complexity of the whole thing. So reducing
lines of code will actually go lower.
Yeah, that's fascinating. So you're doing fusion of all the sensors, so reducing the complexity of having to deal with each
fusion
sensor.
of the cameras is not cameras really.
Right. Yes.
Yeah.
Same with humans. Well, I guess we got ears too. Okay.
Yeah, we'll actually need to incorporate sound as well, because you need to like listen for ambulance sirens or fire trucks. Or if somebody like yelling at you or something. I don't know. Just there's a little bit of audio that needs to be incorporated as well.